Hello. How do we know what pi is? We have all these digits, how do we know? Now in the early days, people used to just measure. You got something round, you measure across, you measure around, you're able to come up with pi to 1 decimal place, usually. Some civilizations couldn't even get that far. But if you want to get all these digits, you're going to have to calculate. Now, one of the ways of doing that is something called the Nilakantha method, which I'm sure I'm mispronouncing, but let me show you how that works. Okay, so 3, we start out with 3, and it works like this. 3 gives us the first decimal point. 3 plus 4 over 2 times 3 times 4. And if you do that, you're going to find that what you get is 3.16 666. Now you might say, oh, I've got the second digit. Well, no, you haven't, because if you round this, you're actually going to round it up to 3.2. So you don't even have it to the level of precision that ancient people were getting simply by measuring. So you have to do a little bit more than that. So you notice your number was a little bit on the high side, 3.16. So we're going to actually subtract, and minus 4 over 4 times 5 times 6. When you do that, you end up with this number. You end up with 3.1333333. Now, we do have that second digit, 3.1. So we're now up to the level of precision that you get just by simply measuring the circumference and dividing it by the diameter. So let's take this, but let's keep calculating, shall we? So our number is a little bit on the small side. We're going to go bigger. I think I'm going to use some blue here. Plus, so 4 over 6 times 7 times 8. Now if I do that, I end up getting 3.1458, or no, 452. It doesn't matter anyway, it's not really pi. Now you say, oh, there's that second digit. Nope, not quite. Because if you rounded that, you rounded it up to 3.15, so we do not have our second decimal yet. Our number is a little too big. Subtract 4 over 8 times 9 times 10. When you do that, you get 3.1396 something. And now you are actually there, because what would happen, you round that up, you get 3.14. So we can say, yes, we finally have that 4. So yes, we've finally gotten the decimal place that we want, 3.14. So that's about as far as I've memorized pi, but we can calculate even further here. How should we do it? Well, let's change color. And how about red? Red's a good enough. Okay, so that was minus. Now it's plus. Notice it's going plus, minus, plus, minus, plus. Okay, plus 4 over 10 times 11 times 12. When I do that, I end up with, here it is, say 3.142713. So we're not quite there yet. Okay, let's try a little further. I'm going to have to give myself some more room here. 4 over 12 times 13 times 14. That would give me 3.1408. Now, 8. Now at this point I can say, I can round up to get 3.141, can't I? So that's what I will do. I will round it up. But, and I wanted to actually talk about this a bit. So, we got this here. So, we have figured out our 1. Shall we keep going? Let's keep going. Okay, so, plus 14 times 15 times 16. And we end up, let's see, if we do that, 3.1420 72. Nope, still not there. Go with the next one, subtract 4 over 16 times 17 times 18, and I get 3.14125. And you know, I could keep going on, but I want to actually stop right here because I want you to see something. So you started out with the first digit, right? 3. You did 2 more, I don't know what you would call them, clusters, and I got the next digit. 2 more clusters, I was able to get the next digit. 2 more clusters, I was able to get the next digit. But notice over here, I've done 2 more clusters, I end up with 3.14, and it's 125. If I round that up, I get a 3 here, not the 5. I'm going to need another cluster before I'm actually getting to the level of precision where I can actually get the next digit. And this shows you a little bit about the problems of calculating pi. It is a lot of calculating. All this just to get to 3 decimal places. I've gone even further. I haven't even gotten to 4 decimal places. When you think about people who have calculated pi to 3 trillion or 30 trillion decimal places, imagine the computing power. Because also one of the things you'll notice is not only do I have to have more units, more modules here, the numbers are getting bigger. The numbers are getting bigger, and we're needing more of them to get each additional digit. It can get crazy. Adding 1 more decimal to pi involves a lot of additional work. Adding millions is a crazy large amount of work. So just appreciate what goes into making those crazy calculations of pi. Bye-bye.